Hi kids! Video 4 is on graphs and trend lines. Your essential question is, how do we use graphs to show the important trends in our data and to make predictions? You may have done graphing in middle school. If so, great. This will be a review, but we're going to also learn how to do digital graphing in a separate video or later on in class. Just so you know, your graphing is going to also be assessed under SE1, your experimentation proficiency. And we are expecting you to be able to create a graph that includes scaled and labeled axes, accurate data points, and a trend line or curve, which is what the most important thing about the graph is, and we'll be talking about that in this video. I'm sure you made a lot of different kinds of graphs in middle school, but almost all real science experiments are graphed using the Scatterplot, and every graph that you're going to make in this class, we're going to be making with a Scatterplot, which is basically a graph that shows just the data points that show a relationship between the two variables. In this case, the two variables are the hours of video games someone plays and their grade point average. The reason why we use scatterplots is because this lets us present a lot of data really efficiently and see relationships. The trend line, which we talked about earlier, is going to be sort of the summary of that data. The individual data points have error, but the trend line tells you the overall relationship or what's happening when you change one variable. So that's a really important part of the graph as well. So we're going to quickly go through how to create scatter plots. You're going to start with your data table, and you need to identify which variable in your data table is your independent and which is the dependent data. Generally speaking, the variable that you're measuring is dependent and the one that you sort of control or change is independent. But a rule of thumb in this unit for the motion unit or movement unit is that time is always going to be independent. It's just kind of protocol and standard for this unit. So if your data is distance versus time, we're always going to graph time as the independent variable, and we're always going to make distance our dependent variable. So the second thing that you're going to do is to label your x-axis with your independent variable and the y-axis with the dependent variable. Make sure you include the units, so in this case meters and seconds, that your data was measured in. The third thing to do is to come up with the scale or the range of values. You want to look at your data table to figure out what the smallest and largest values need to be on each axis. And then I usually choose kind of a clean round number, slightly bigger or smaller than the range to graph. Often, but not always, 0 is going to be at the origin. I would say in this class, put 0 at the origin unless there's a really, really good reason not to, because we're really interested in the intercepts of the graphs, and you won't be able to tell anything about the intercepts if you don't put 0 at the origin. Make sure you label all the maximum and minimum values, and then you can figure out how big each of the squares in between is by just dividing the whole range by the number of squares that you have on your graph. The next thing to do is to graph the data. I recommend using a small x instead of a dot. You may have used dots in the past, but when you put dots, when you add your trend line in a few minutes, they often kind of get covered up, and I really want to be able to see the data and the trend line. So you sort of look at your data points, and you're going to figure out where they fit in this x and y axis. You should have learned this in a previous science or math class, but if you need help, please come see your teacher. The last part of the graph, and this is something that I tend to find most middle school students don't have a lot of experience with, is drawing trend lines or trend curves. A trend line should be a dashed line or curve that shows the overall trend of the data. And this is really, really important in physics. And a couple qualities of trend lines. Number one, it should definitely not be connecting the data points. So don't do a connect the dots thing. That would mistakenly show that you have this really crazy relationship where sometimes it gets steeper and shallower and all sorts of stuff going on. So you're just showing the overall trend. In fact, your trend line might not go through any of your data points, and that's totally fine. It is worth mentioning that trend lines are not always lines. Sometimes they're curves, but you generally want the simplest trend line that you can use. So if a line will work, we'll use that first. If your data really, really shows that it's a curve, then you could make a curve for your trend line as well. So figuring out what your trend line should look like and creating it on your graph is the most important part of the graph. The reason it's so important is because you can use your trend line to make predictions about variable values without having to take every single data point. You can just say, hey, I can tell that this is what's happening, so I bet that my data is going to be whatever it's going to be. You also can use that trend line to figure out what the mathematical relationship between the variables is. We've learned about three: no relationship, linear relationship, and inverse relationship. And those three trend lines look really different on your graph. So if you make a graph, you can actually figure out what the math should be. So for example, if you make a graph and the data looks like that, a nice flat line, that's the most likely trend line, and the most simple trend line is a straight line across a graph. That would be the trend line for no relationship. That says that no matter what is happening to that independent variable, your dependent variable value is not changing, or it's unpredictable. However, if your data points show up looking like this, kind of a slanted upwards line, that is showing that there is a relationship between the variables. Specifically, it's a linear relationship. When the independent variable is going up, well, the dependent variable is going up by the same percent, right? So when one of those variables doubles, the other does as well. And this may show you why this is called a linear relationship, because it makes a nice trend line that is straight. If you have a bunch of data that looks like this, okay, that's one of those examples of I've got a whole bunch of data and it's clearly curved, so I'm going to draw a trend curve instead of a line. And that curve is the curve for an inverse relationship. It shows that when one variable doubles, so when your independent variable on the x-axis gets bigger, the dependent variable is actually getting smaller by the same ratio. This is kind of an interesting trend line because it doesn't have any intercepts. You'll notice that it is going to get close to the x-axis, closer and closer and closer as time goes on, but it never should actually cross, and the same is true for the y-axis. That's because no matter how many times you divide a number by half, it never actually reaches zero. So this would be the trend line if you have an inverse relationship between two variables. Okay, so please take a few minutes to summarize this video and revisit that essential question: how do we use graphs to show the important trends in our data and make predictions?